right, our last section, services and management. So in services and management, the first one is configure IPv4 DHCP on DLS1 and DLS2 to provide IP addresses, subnet mask, DNS, I should say default gateway information to the VLANs 10, 20, and 50. I'm gonna do it on both of them, so I'm basically gonna split the network in a sense. I'm just gonna exclude half of it on each side. So each one will only hand out half. That way I can also tell which if DLS1 or DLS2 handed out the address without having to look at the binding. All right. IP, so we got to configure 3 separate pools, one for VLAN 10, one for VLAN 20, one for VLAN 50. And I'm going to name them the pools VLAN 10, VLAN 20, VLAN 50, so then I know which pool is servicing which subnet. So IP DHCP pool VLAN 10, network 10.10.10.0. We need to have a bit length or a subnet mask here, otherwise it'll summarize the network back to classifiable boundaries, so it'll hand out 10.0. It'll hand out everything in the 10.0.0.0 network. DNS, we don't have one running, so just pick one. Just use a public DNS, so we'll use 8.8.8.8. The default router is the standby IP, right? It's the HSRP virtual router IP. So the default gateway is 10.10.10.3. That way, if you fail over from DLS1 to DLS2 or vice versa, the host has no idea. It's using the same address regardless. Done. IP DHCP pool, VLAN 20, network 10.10.20.0, the 24-bit subnet mask. We'll do our DNS again. 8.8.8. And the default router again is 10.10, and this time it's 20 because we're in the 20 VLAN. That's the standby IP, which is also how it'll get off its own subnet. So it's the default router. IP DHCP pool. That's not spelled right. DHCP pool. VLAN 50. Can't have a space in the word. There we go. Network 10.10.50.0. You could also do a subnet mask here. Type out a subnet mask. Just doing it differently, I guess. 8.8.8.8. And the default router 10.10.50.3. Now what I want to do is I will exclude my addresses. I'm going to exclude on this side, on DLS1, I'm going to exclude everything from .1 to .110. So IP DHCP excluded. So in the 10 VLAN, it'll be 10.10.10.1 to 10.10.10.110, which means the first address this DHCP server on DLS1 can hand out is 111. Because 1 to 110 is now reserved. Let's hit the up arrow, so we have to keep typing it. Change this to the 20 VLAN subnet. So we'll exclude addresses 20.1, oh, okay, 10 dot, not comma, dot. Addresses 20.1 to 20.10 in that subnet. And up arrow will change the 20 to a 50. So I'm excluding part of the pool in the 50 subnet. All right, DHCP is done on DLS1. So if we went through it, we created our pool, named our pool, gave it the network from which it can pull addresses, gave it DNS that it can hand out, and the default gateway or default router information that it can hand out. And then we excluded part of the pool. So none of those addresses, it can't hand out any of those addresses. All right, let's go to DLS2. And do something pretty similar. Big D. We use the same pool name, IPD DHCP pool. Wow. VLAN 10, one word. Network 10.10.10.0, 24 bits long. DNS server. And the default router is the same. This would have been a good one to probably put in Notepad because this information is all the same. Like I said when I did earlier where you copy and paste it in. That would have been a good idea on my part. VLAN 20 pool. 10, 10, 20, 0. Our DNS server, and our default gateway, or default router as they refer to it in DNS, or in DHCP, sorry. 10, 10, 20, right? I'm in the 20 pool. I just did 10. 20, 20.3. Okay, last is VLAN 50 pool. Exit. IP DHCP. Come on. CP. .0/24, our DNS server, not our DNA server, and our default router. 10.10.50.3. Done. Now I'm going to do two different statements because I want to exclude the range of addresses above 110, but I also need to exclude addresses 1, 2, and 3, right? Because they're statically assigned somewhere else in these VLANs. Because they're statically assigned, right? DLS1, DLS2, each has a VLAN interface with a .1 and .2 in that VLAN. And then we use the standby IP of .3, so I need to exclude those as well. So I'll do IP DHCP excluded address. 10.10.10.1 to 10.10.10.3. Now let's hit the up arrow because the other ones we want to exclude are the ones that DLS1 are going to hand out. So then that would be 110, 10.10.10.110 to 10.10.10.254. And we'll do the same thing for the 20 network. It's 10.20.40. Now I got to go back to 10.20.50. So hit the up arrow until I get back to what I already entered in. Change that to the 20. So now we exclude the 20 network, the 20s. And the same thing for 50. All right, now we've excluded everything we want to exclude. The 1 to 3s that were actually statically assigned. And then the 110 to the 254 that DLS1 is going to hand out. Now DLS2 can hand out everything from 4 to 109. I think that's it for DHCP. Configure NTP on all devices. R1, R3, and all switches will get their clock information from R2. So let's bring R2 over and tell him he's the master. He's the NTP master. That's all I need to do on R2. So now we got to configure the rest of them. R1. You know what? First, I should probably make sure I have not checked connectivity up to this point. So 10.10.1.41. That's the loopback address of R2. So let's go ahead and use that as our NTP server. FigT NTP server 10.10.1.41. Okay, and I will grab R3. See if that's a little easier. There we go. And same thing on R3. Config T NTP server 10.10.1.41. Okay, keep doing that all the way through. Let's do DLS1 just so you see a switch. But basically, it's all the same command. NTP master in order to enable NTP on the device that's going to provide clocking. Ooh, I should have also changed the clock too, just because. I mean, it has a clock in it right now, but let's go through. I'll go through and do that after I do this. NTP server 10.10.1.41. Do that on all the devices except for R2, which is the one that's going to be providing clocking, right? So R2 is the master. let's bring R2 over and change the clock. Oh. Setting the clock is actually done in privileged exec mode, so I had to back out one. We got the hour, minutes, and seconds. Let's set the clock to, I don't know, 5 o'clock. And 25 seconds. And then you can go month or day. So let's do 22, October, and then the year. So now we set the clock as well. Now normally you would set the clock before you would tell everybody, you know, I'm the master. Before you'd set up the rest of the NTP, set the clock first, NTP master, then NTP server on all the NTP clients or all the devices that would be getting their clocking from NTP. So that one's done. Configure, I need my pen, figure out where I'm at. Configure AAA. Configure AAA to use radius first, and if the radius server is down, to use local authentic. I don't really say which device or all devices. We'll put it on, let's put it on R1. Or not. Thought it was right behind there because it was white. I have the 2 switches. Of course not. Just a sec. There we go. There's some R1. Now let's go ahead and configure R1 for AAA to use, what do we say again, radius first, local. And because we're in lab, I'd also add none. And only because we're in lab. That means if all my other methods fail, not because I entered the password incorrectly, but because they're actually down. So like if I do radius and local and none, if the radius server is down or I can't communicate with it, it'll go to the local method. If I didn't configure a local username and password, then it'll go to none, which works out really nicely in lab because you know it's just so many times we accidentally lock ourselves out, so we don't want to do that. So let's first configure our username. We're just going to configure a username of admin with a password of admin. And then we're going to configure AAA new model. We're going to enable AAA, so AAA new model. Then we're going to configure our authentication method. Login. I can give it a name other than default, but then I have to apply it. So if I call it console, then I have to do authentication login console on the console lines. Okay. So this will actually just apply to all of them if I use the keyword default. AAA authentication login default group radius local and then none. So first it will look to try to authenticate with the radius server. If your username and password is bad, then you fail. You just simply don't get in. But if it tries to communicate with the radius server and I can't communicate with the radius server, meaning it's down, I didn't enable radius on the server, whatever, then it will go to local method. It will go look for the username and password of admin and admin. If I didn't create a local username and password, then it will default to none and just let you in. So we go ahead and do that. Then we've got to actually configure our AAA server. Oh, radius server. I'm going to just give it a name. We're going to call it SRV. And then the address family, address IPv4. And we're going to actually use the server address, so the actual SRV1 in our topology. So 10.10.40.10. Is that right? Yeah, it is. 10.10.40.10. And then remember, Cisco uses legacy ports still in its iOS. And so you have to set them. I think there's 1645 and 1646 are the legacy ports. We need to set the ports to 1812 and 1813. So the auth port is 1812. Oh. And the count port or counting port is 1813. Done. Now we've got to create a key or a password that allows this router to communicate, or that I mean it's pretty clear, but that will then have to authenticate with the server itself. So whatever the password is on my router has to be my password on the server, otherwise the two won't communicate. We're going to use WinRadius. That's the default in the free WinRadius software we use. You can change it to anything, and I can go into WinRadius and change it as well. I just know that this is the default. And that is it. AAA is configured. Like I said, if I had used the name instead of default, then I would have to apply it to one of the lines somewhere. We'll test everything here in a minute. All right, so I want to bring my PCA over, my server. Actually, I should check two things. I should check to see if I got DHCP from PCB. And I should set up WinRadius. So this is the server here. And we go to WinRadius. I don't know how much of this you're going to be able to see with this little window. Operation. Here. Operation add user. This part you don't really know. It has nothing to do with the configuration really of the devices. It's just if I want to test that they're working. Add WinUser or WinRadius is what we have in the classroom. So admin and admin are my username and password that I'm using. Click OK. Settings. System. Double check that the key is in fact WinRadius. The authorization and accounting ports are 1812 and 1813. Settings. Data. Oh, I have to configure ODBC automatically. I think that's all I want. So then I'm going to have to close it though because I have to restart it. I'm surprised my users were loaded because I did it backwards. My users are loaded. It looks like I'm running okay. Let's see. Well, how if since we're already on this device, let's go ahead and we're on server. Oh, Telnet's not going to work yet. I was going to say here go into the VTY lines real quick, but it's not going to work because we didn't configure it. One, the default for the VTY lines is going to be transport input none, so it's not going to work yet. I see that we have an SSH, so we'll go ahead and use that when we get down to that part. We'll test that when we get down there. So we've configured the WinRadius now. We're going to end the we configured the radius on the device in the WinRadius server. Once we've configured SSH, we'll verify that it works. So configure AAA use radius. Done. Configure SNMP in all devices with one read-only community and one read-write community. Configure the devices to send SNMP information to the manager. That there is just configuring traps. So by default, SNMP is more of a polling device, which means the server, when it wants information, when it's prompted to pull information, it will pull from the router or the switch or whatever. If I want the device to be able to send information, then we have to actually do another configuration or additional configuration line, which is just to enable traps. So R1's been my focus, so we'll do R1 again. Config T. SNMP, we want two, all right? Two string SNMP dash server community. This is SNMP version 2, by the way. No real security here. We could do access lists to at least specify that we only want it to come from one host. SNMP version 3 actually adds some additional security to it. So SNMP community, our community string is going to be CNIT 444. So often people use public and private, but if you think about it, when you download an SNMP server, it's going to use the default public and private. So if you're using those as well, I can pull information from your devices, most likely. Especially with this config without some sort of an access list to say only this host can pull information. SNMP server community CNIT 444, this will be our read only. And then if we go up, we're going to go CNIT 444, we're going to call it that community string CNIT 444 admin. And that one's going to be our read write. Which means kind of we can configure devices a little bit. We talk a lot about programmability and stuff, but in a, like as if it's a buzzword nowadays, but in a rudimentary way, we were able to remotely kind of program devices through SNMP. Which is kind of dangerous. If you only need read-only, that's all you should probably have. But I wanted you to do both, so we did it. Now we've got to configure our host. So where is our manager sitting? Where is our SNMP manager sitting? That's going to be on our server. SNMP-server host 10.10.40.10. Version of SNMP is 2C. And the community string I'm going to use is CNIT 444. And then the last part is that I have to enable traps. So SNMP right? So that's that next bullet point is configure devices to send SNMP information. Configure the devices to send SNMP information to the manager. So SNMP server, enable traps. And that actually creates a lot. So if I do show run here, I probably should have began at SNMP, but that's all right. When we enable traps, it enables all kinds of variables. So we only configured a few of these things, but as soon as you enable traps, you've got all kinds of great things that can happen. Here, okay, let's also do our server for our rewrite community. So SNMP-server host 10.10.40.10 and the version CNIT 444 admin. So now we've got them both in there. I did traps, did both our servers, did both our communities, and set them up both for the host. So our SNMP is good. And just repeat that on all the other devices. So I wonder if I've got, probably don't have it up. So you just go through, this would be a great option for copy and paste, right? The SNMP commands, the ones we actually put in, because we didn't really put that much of it in. Let's see. Let's just do it. Let me pause for a second just so I can get some notepad here. And then, all right, let's pull some notepad over here. Let's just pull out some of these ones that we put in there. So we had the communities, right? And then we've got to have our hosts and our traps. The hosts are probably going to be, I hit Q in there. Well, no, that's right, we can just do these. Well, we can do one of them. You know what? Show run. You just show everything that includes those. Then we can just copy that, paste that over to our notepad, and the SNMP-server enable traps. We can just copy and paste this. This is a pretty basic command, pretty basic. You know, we could also add an access list, like I said, that would specify only a particular host or a subset of hosts that could actually pull in SNMP information. We'd copy, bring that over to, let's say, it's on all devices. We'll just do a couple of them. So we'll do our 3. That one, paste it in. Let's do one more for good measure. And like I said, if you're doing them all and getting all your configs done, you just configure it in all of them. It's just a matter of copy and paste once you put it in Notepad. And we're done. SNMP. We only have one thing left, right? Yeah, because we did SNMP, and as part of SNMP, we did the next bullet, which was to allow the devices to send without the manager first having to pull, which is to enable traps. Configure SSH on all devices. Okay, again, we're going to do one, and then you just repeat it. I think because we configured AAA on R1, and we want to verify that it will use AAA when we try to come into, say, the VTY lines that we want. Let's go do it in R1. That is not R1. I love it when I say that, and I think the window is like right behind it. It's not. Okay. I only got 2 white windows, so it should work here. I tried to color code them a little bit. All right. Domain name. We need to have a domain name for SSH. We'll do CNIT 444. Did I give you? I didn't say like. Oh. So crypto. Oh, no, we got a username, right? We did all that. We have username and password because we did that for Radius for our local database, our local authentication. So crypto something. Crypto show IP. That's not what I want. Why am I drawing a blank right now? Crypto key, wow. Crypto key, generate RSA. See, I just need to get that one word, then I was good. I just, for whatever reason, had a brain fart. Modulus, 1024. And then it should generate our RSA keys. And then we got to go into our VTY lines and enable SSH. Line VTY 0 to 4. Transport input SSH. Now let's see if it'll work. Let's go back to our server. First, see that we can ping R1. What was R1's address again? You know what? Let's just, instead of me trying to search for my paper here, do show IP int brief. Closest one is going to be 10.10.19. So let's just ping 10.10.1.9, 9, just 9. Okay. Let's just open up TerraTerm. 10.10.1.9. Already set for SSH. Username is admin. We'll continue through that. Our password is admin. Click OK. We were in instantly, which is good. And our user authenticated, which means we did use Radius. All right, let's do one more. Instead of doing it from PC, let's do it from a device. So we'll go from R2, SSH-L. The username is admin. And the address we're going to go to is 10.10.1.1, which is R1's connection to R2. Oh, shoot. Let's clear that out. Typed in admin, and then we're authenticated. So we're working. Everything seems to be working. No, we didn't check to see if our PC was getting a DHCP address. So let's get PCB over here. The one that's actually pulling something through DHCP. Or should be, hopefully. 10.10.10.4. We'll do a release and renew. Hope it's still going to pull it. Never know what happened during the configuration. And we did pull 10.10.10.4. All right. Let's see if we can ping from this PC to 10.10.1.41. Ho, ho, ho. So we have connectivity. And we're done. We've configured everything. We can get where we need to go. I think we're good. One other thing we could do is check our translation. So if this is going to the loopback on R2, so we could check to see if we got a NAT translation. Let's clear our NAT translations first. We'll just do it again. Clear IP NAT. Okay, show IP NAT translations. Okay. And we go over and ping. Whoa. Let's get this window after everything kind of moved on me back where it's supposed to be. Okay. Let's go ahead and ping again and double check our translation again then. See that it held our dynamic NAT, that it correctly translated to our pool. Do another show IP NAT translation, and we do translate our 4 address to our pool. So we're good. NAT works. We have connectivity. BGP works. That's it.